5.1 and 5.2, finding the minimum and maximums of a quadratic function, including also finding the domain and range. So the maximum, max or minimum, min, is the single highest or lowest point of the quadratic. Thus, the max or min will always be located at the vertex. So it's located at the vertex, so you need that. You will always use your k value of your vertex. Okay, very, very important here. So max is the highest point when your graph opens down. So if your graph looks like this, here's your maximum. If your graph looks like this when it opens up, it's going to be your minimum, your lowest point. When we talk about the domain and range of the function, we want to know for what values does it make the graph true. Meaning, if I pick a value for x or y, will I be able to put it on the graph? So the domain, you should know are the x values, the range are the y values. So when talking about quadratics, domain will always be all real numbers. This one will not change when we're talking about something with an x squared. Range, however, will be different each time and will be based on your k value. It should be written in set builder notation. So remember, set builders looks like this, and we're going to fill this in right here. It's y because range is y. So, example 1. Find the minimum or maximum value of the function. Then state the domain and range of the function. Okay. If it is in standard form, remember we have to find our k, we have to find our h. And h is that formula x equals negative b over 2a. We talked about this formula last time. So negative 2, so negative 2 over 2 times a, which is 2. So that's positive 2. 2 times 2 is 4. So 2 over 4 makes 1/2. Okay, now I'm going to grab my calculator here and plug that back in to get my k. So that is 2 times 1/2 squared minus 2 times 1/2 plus 5. Let's see what that is. So that's our k. 2 times 1/2 squared minus 2 times 1/2 plus 5 is 4.5. So our k is 4.5. Okay, so I need to know, is it a maximum or minimum? Okay, because this is positive, that means it opens up, right? And opens up means it has a minimum. So our minimum is k equals 4.5. And I want to see it look just like that. The other thing we need to know is our domain and range. Remember I said the domain is always all real numbers. We're going to write it just like that, the funny looking R thing. The range, it's going to change each time. It's going to look just like this. Now, that's set builder. What you need to know is if this is a minimum, that means this is the smallest number possible. So that means any number I choose has to be bigger than that. Okay? So I'm going to write y has to be greater than or equal to 4.5. And that's also my answer I'm looking for. So that means 4.5 is this number here. Anything above that is what I can do. Now this one, same thing. So x equals negative b, so negative 6 for 2 times the 1 right there. So 6 over 2 is 3. And we have to take that 3 and plug it in. So 3 squared minus 6 times 3 plus 3. 3 squared minus 6 times 3 plus 3. That is negative 6. So since this opens up, so that means up, so that means we have a minimum again. K equals negative 6. Our domain, once again, is all real numbers. And our range, y bar, y has to be greater than or equal to negative 6. That's our other answer. This number always goes right there. Always, always, always. Last one. Okay. Now there's no regular x here, so it's 0, right? So x equals negative 0 over 2 times negative 2, Well, if 0 is on top, it's going to automatically be 0. So if I plug this back in, negative 2 times 0 squared minus 4, that goes away because it's all 0, just gives me negative 4. Because it's a minus, it opens down, right? And if it's down, that means I have a maximum at k equals negative 4. Once again, domain is all real numbers. Range, though, because it's a maximum, will now be less than, instead of greater than, less than or equal to that negative 4.